Welcome back. Today we're going to talk about representing proportional relationships. Okay. First, we're going to start with a definition of proportional relationships, which you have seen in 7th grade. So a proportional relationship is a relationship between two quantities, okay, in which the ratio of one quantity to the other is constant. So if you make a ratio or a fraction of one quantity to the other one, it's always constant. All right. A proportional relationship can be described by an equation of the form y equals kx, where k is a number called the constant of proportionality. All right. So it's really important if they ask you, sometimes they'll ask you what the constant of proportionality is. It's whatever you multiply x by in order to get to y. Another form of the equation is k is equal to, so if I solve this for k, I would divide each side by x right here. It would get rid of it on this side. So we have y over x is equal to k. So if I'm solving for the constant of proportionality, I take the y and I divide it by the x. Okay, this is how you represent proportional relationships in tables. So for instance, Megan earns $12 an hour at her part-time job. The table below shows the relationships between the amount she earns and the number of hours she works. So this is the amount, this is the money that she earns, 12, 24, 48, and 96. And the relationship with the amount of hours that she works. So for 1 hour, she gets $12, for 2, 24, 4, 48, and 8, $96. Write an equation to describe the relationship. First of all, in order to write this equation, y equals k times x, we're going to have to find the constant of proportionality, okay? So in order to do that, I have to think about, well, let's look at the relationship between the amount that she earned over the number of hours that she worked. So here we have 12 divided by 1, which is 12 over 1, okay, which is also 12, okay? So the next one we have is 24, she earns $24 for every 2 hours, so that reduces to 12 over 1, or 12. And the fourth one we have 48 over 4, which is 12 over 1, which is 12. And we have 96 over 8, which is 12 over 1, which is 12. So for every, if x is the amount of hours that she works, and y is the amount of money that she earns, we'd say that the amount of money that she earns is equal to $12 times the amount of hours that she worked, which is the way that you could sort of think about it in terms of what the word problem has set up for you. Okay. Notice that her constant, that her relationship here between the amount of money that she makes and the amount of hours that she worked is proportional. It always create, like the ratios create equal, or the ratios that are created, 12 over 1, 24 over 2, 48 over 4, that it's constants, right? So this is the same as this one, is the same as this one, is the same as this one. And remember, proportional relationships is the ratio of one quantity to the other is always constant. So this situation right here is a proportional relationship because the ratio of the amount of money that she earned to the amount of hours that she worked is constant. All right, so we can say that this is a proportional relationship. If there's any time where you divide one by the other and you don't get 12, it means right there the existence of one number that doesn't get 12 means, or the existence of one ratio that's not equal to 12 means it's not proportional. But since all of our hours work out here, it's fine. Okay, here's another type of proportional relationship. But this time, instead of using a table, we're going to look at it in terms of a graph. The graph below shows the relationship between the weight of an object on Earth and on the moon. All right, so along the x-axis, we have the Earth's weight. So 6 pounds on Earth is going to be equal to 1 pound on the moon. 12 pounds on Earth is 2 pounds on the moon. 8 pounds on Earth is going to be 3 pounds on, or 18 to 3 is the relationship between Earth and moon weight. So what you can see is that actually the Earth's weight is heavier than the moon's weight, right? Because the Earth has more gravity than the moon. So the relationship between them is that you weigh more on Earth than you weigh on the moon, or objects in general weigh more on Earth than they weigh on the moon. Okay, we want to write, whoops, that should be an equation for this relationship. All right, so let's think about it. if I write a relationship, I want to think about, we want y is equal to k times x, because this is a proportional relationship, right? We said that proportional relationships can be written in this form. Okay, well, what is the y variable? So this is the y-axis, the vertical axis is the y-axis, and this is the x-axis. Okay, so the y-axis is the moon's weight. So moon is equal to what, I'm looking for k here, times the earth. Okay, so what I don't know is I don't know what multiplies in order to get that. So we could actually, remember we said that the other form of the equation is k is equal to the y over x, and that would be a moon weight over an earth weight. Okay, so let's pick up one of these points right here. Okay, this point is 18, 5. Actually, let's pick up a little easier point. Let's use this one. This is 6, 1. Okay, so that means that 1 pound on the moon is going to be 6 pounds on the earth. Okay, so our k is actually going to reduce. So I notice I eliminated my unit here because I have pounds over pounds. So my k doesn't have a unit on it. It's just 1/6. So every time I take an earth's weight, I have to multiply it by 1/6 in order to get the moon's weight. So you can see that here. Whoops, and that's supposed to be, it's not 18.5, it's 18.3. So this is 18.3 here. So 18 times 1/6 would be 18 times 1 over 6. You'd put 18 over 1. You get 18 divided by 6, which is equal to 3. So you can see that k is consistent throughout all of these points. This would be 12.2. This would be 35, 30, 5 here. So that is, that k is the constant of proportionality. So the Earth's weight is proportional to the moon's weight by 1/6. 1/6 of the Earth's weight is equal to the moon's weight. Or if you want to put it in terms of the equation, we'd say the moon's weight is equal to 1/6 times the Earth's weight. Okay? Or y is equal to 1/6 times x. And you'll notice all of the points that we have here, so the points that are sort of integer values, here are 6, 1, we had 12, 2, we had 18.3, and we had 35, 30, 5. So all of these, you can see that the x coordinate is, or the y coordinate is 1/6 of, remember the of is a multiplication, is 1/6 of the x coordinate. So you take the x coordinate, multiply it by a 6 to get the y coordinate. Okay? Okay, so now I want to talk about looking at another type of graph and figuring out from it what a point means and what the equation of the line is. Okay, the graph below shows the relationship between the amount of time that a backpacker hikes and the distance that they travel. Okay, so the distance that they travel is going to be the y variable, and the amount of time that they hike is going to be the x variable. That's because the distance that they travel depends on the amount of time that they've been hiking. All right, so the y is always the dependent, and the x is always the independent. And I always like to set up a situation where I say blank depends on blank. So I try to fill in the variables into this sentence so that I can figure out what the dependent and the independent is. Here it's given as a graph, so it's a lot easier to figure this out because, of course, this is the y-axis, which is always the dependent axis, and this is the x-axis. So it makes sense that the miles traveled depends on the hours that one has been traveling here. So usually this sentence that I create is more useful when we're given a word problem. We have to determine from the word problem what's dependent and what's independent. Okay, so what does the point 5, 6 represent? So this is this point right here. Well, here the 5 is the x variable and the 6 is the y variable. Well, what is the x variable for this specific problem? 5, 6 this is x and y in general, but for our problem specifically, it's hours, miles. Okay, so the point 5, 6 represents for 5 miles, or after 5 hours, sorry. I should say after 5 hours, you've traveled 6 miles, right? So after 5 hours, you've traveled 6 miles, or the hiker has traveled, you have traveled 6 miles. Or I should say the hiker, really, because you're not traveling this, it's this guy. What is the equation that represents this relationship? So remember, in order to get that equation, first let's get the constant of proportionality. That's the y point over the x point. Okay, so here we have 5 over 6. Nope, I'm sorry. I made the common mistake of putting the x over y. So here, this point is 5, 6. That means it has a 6 as a y coordinate, sorry, and 5 as an x coordinate. Let's make sure that that's proportional to all the other points here. So 12 over 10, those are reduced to 6 over 5, and this point is 15, 18, which is 18 over 15 if I'm looking at k. And so all of these are the same point, so this is a proportional relationship, so the ratio of y to x is always constant. That means that y is equal to the constant of proportionality, which is 6/5 times x. So this is my relationship here. And sometimes when we have this on a graph, it's good policy to put the equation of the line on the graph. Okay, so we've gone over what a point means, we've gone over how to find an equation, and we've gone over proportional relationships. That's the end of the lesson for today.